Hello and welcome everyone to this webinar about the final comparison between Creo and Solidworks. I'm Richard Bressan, the account manager at Parametric Design Canada, and thank you so much for joining me today. So today with me there is Marco Bellusci. Marco Bellusci is the technical application specialist and multiphysics simulation analyst, and will be sharing a comparative analysis between the two well-known CAD software, Creo and Solidworks. I'd like to invite you to write any question you may have to our email address at contatti@parametricdesign.com. So, during this webinar, we embark on an exciting journey into the world of CAD design, comparing the two industry giants, Creo and Solidworks. So I'm thrilled to explore the capabilities of this powerful platform and help you make informed decisions for your design process. So throughout our session today, we will delve into various aspects of both Creo and Solidworks, covering a range of topics designing to give you a comprehensive understanding of their features and functionalities. We will begin by taking a closer look at the user interface of Creo, exploring its simplicity and efficiency in facilitating seamless design workflows. From there, we will delve into the realm of managing large assemblies, discussing techniques for optimizing speed and performance. Next, we will shift our focus to the process of creating large patterns, uncovering tips and tricks for accelerating your design interaction. We will then explore some of the key features included in the Design Essential license, highlighting their significance in meeting your design requirements. Moving forward, we will dive into advanced topics such as piping and cabling, human factors, and collaboration tools. We will explore how these features enhance the overall design process and contribute to the creation of more innovative and ergonomic designs. Additionally, we'll explore some of the more advanced capabilities of both platforms, including industrial design and surface modeling with ISDX, virtual testing and simulation with Simulation Live, and reverse engineer with Rex. Finally, we will wrap up our session by examining how these platforms fare in the competitive landscape, offering insights from the ABI Research Competitive Ranking. So by the end of today's webinar, you will have gained a deeper understanding of both Creo and Solidworks, empowering you to make informed decisions that align your design goals and objectives. But before we begin, allow me to provide you an overview about Parametric Design Canada. So at Parametric Design Canada, we are technology advisor, specializing in helping companies excel in their product development process throughout powerful and innovative software solutions that adapt to various market needs. As an authorized retail and partner for an esteemed software provider such as PTC, Parametric Design Canada offers comprehensive product suite to meet your requirements. Our range of solutions includes CAD 3D, PLM, ALM, augmented reality, and industrial Internet of Things. We are, of course, recognized as a valuable partner, and with us you gain access not only to a software solution provider, but also to a dedicated team of professionals who are passionate about your success. Here are just some of our industry's references. So transportation references, as you can see, we have names such as Piaggio, Beta Motors. For the design references, we have we work with Tiffany & Co. or Momo Design. In the oil and gas references, we have names such as Paul Wurth. And in the consumer goods, our clients include Lavazza, Ferrero, Bialetti, and Samsonite. Our expertise also extends to medical and wearable technology sectors, where we work with prominent names. And our industrial references are Kohn and Schindler, the elevator maker, and so on. So, without further ado, let's dive into and explore the fascinating world of CAD design with Marco. So, Marco, the floor is yours. enjoy the webinar. Thank you.
Thank you very much, Richard, for your introduction. So, why are we here today? The goal of this webinar is to perform a comparative analysis between Creo and SolidWorks. Parametric design has a 23-year-long experience with PTC Creo. And in this period of time, we had the possibility to work with a large number of clients, different businesses, medical, automotive, oil and gas. So we had the possibility to get to know other softwares and compare with other softwares such as SolidWorks. This experience is allowing us today to answer an important question. What makes Creo different? This is the question that will guide the conversation today. We have identified some key points that most of the time are not known, but can really steer the conversation. We also have identified some misconceptions that need to be debunked. And talking about misconception, let's start from the most important one. It seems that a lot of people are convinced that Creo is difficult to use and takes a lot of time to learn if compared to other software such as SolidWorks. And this is absolutely not true. Let me show you the Creo interface. This is a part model, and this is a very classical interface. We have the ribbon on the top with the commands and all the features organized so they can be easily found. We have the classical tree model, the classical model tree that you can find in every parametric software. Let's try to build a simple model. So for example, I can select this plane and build an extrusion. Let me drop, for example, a rectangle, some dimensions. I can, for example, delete this segment, add an arc here, another circle here, and so on. We have these handles. I can use some shortcuts to change the depth options, and I can confirm. In any moment, I can re-edit the feature and change all the dimensions. I can select this surface and build another extrusion. So for example, let's create, I don't know, another cut here. And as you can see, we can reverse and we can change the option. We can, for example, remove material. We can use the shortcut or the main commands. We can change the depth option and create a through-hole cut. Let's create another extrusion here. Let me drop a simple rectangle. We can associate this rectangle to a new body with the multi-body option, so that, for example, we can use a different color for this new body we created. Let me create another cut here. Just drop few lines. As you can see, the software automatically recognized that this should be a material removal, but I can change the option in any time I want. I can use a symmetrical extrusion with a shortcut, or I can use the classical commands. I can round all the edges of the feature with one click. Add another round here with these very quick commands. Let me use a more advanced feature, a draft feature here with hinge here. No matter of the presence of the round, it's completely, all the tangency are handled. Let me create a shell of this body, remove the surface and change the thickness. At the end, we can simply merge the two bodies. And that's it. As you can see, it's very simple and easy to use, surely not difficult to be learned. And consider that we have a very exhaustive help manual inside Creo, free tutorials and training. Another important key point in this conversation is working with large assemblies. Creo is the leader on the market in this context because it has the highest speed in retrieving, regenerating, and generally working with large assembly. And these characteristics is directly built in this kernel. The interesting thing is that usability and performance also scale as much as the assembly size grows. And even when you work with very large assemblies, Creo is completely stable. You have no crashes. Even if you try to build major changes to assembly or sub-assemblies, you have predictable outcomes, and all these changes are easy to fix. Let me show you an example. So let's try to retrieve a very large model. In this case, I'm talking about an entire train. So we have the locomotive and all the train parts, the carriages. Just to make you as is possible to appreciate, the regeneration only took few seconds, and we are talking about thousands and thousands of components. Let me show you the complexity of it. Just have a look at the locomotive. Inside we have all the engine component, the framework, the pneumatic components, and so on. The same is for the carriages. We have all the seats, a lot of seats. We have the corridor, the toilets, and so on. And all, as you can see, is very clear and without any lags. And we can also regenerate and modify this model very quickly. So for example, let's try to simulate a modification on the entire train profile. So let me grab the skeleton of this model and try to modify the train profile. So let me change this angle. This is a very impacting modification that is going to interest all the carriages and all the components that build the carriages. But as you can see, in few seconds, I'm regenerating the model without any problem. And this is impacting a lot of components, such as, for example, the doors, the profile of the doors, the ceiling, the internal components, and I'm regenerating it without any problem. As you can see, the regeneration is very fast, and generally speaking, Creo can really speed up the design process of any assembly in general. Let's go back to the presentation. The next key point is the speed in creating and regenerating large patterns. Creo is really fast in this task if compared with other CAD software such as Solidworks. We have this example of our client that cut down with Creo the regeneration time from 20 minutes and more to seconds. We are talking about, in this case, a sheet metal grid such as the one displayed in the picture with a large number of pattern cuts. Let me show you in live the example. So this is a sheet metal part, and we have this cut, and we want to fill all the sheet metal with this cut. We simply select the cut, pattern the cut. Let me select the fill pattern and select all the surface. Then we simply have to select the type of grid we want, in this case, hexagon grid. The spacing, 25 millimeters, and if I want, the offset from the border. As you can see, we are talking about thousands of instances. We select the identical option to speed up the process, and we confirm. We wait just few seconds, and as you can see, we had thousands and thousands of instances. In any case, we can change the pattern, select hexagon pattern, and confirm. As you can see, the regeneration is really fast. And this is not a representation. For example, the mass properties are calculated as well and update at every regeneration. So for example, let's try to change the dimension of the cut and regenerate the model. As you can see, we are talking about seconds of regeneration for more than 1,000 of feature, and the mass properties are updated automatically. We can change the spacing, increasing the pattern number, more than 2,000 features or 3,000 regenerated in few seconds. In this case, the final product has more or less 3 grid. So like this, so you can imagine the improvement that Creo can give you. Okay, let's go back to the presentation. Another important thing to consider is the comparison of the package of tools included in the Design Essential package. I'm talking about the smallest Creo license available. This package, it does seem to be far larger than the equivalent Solidworks package. This license has a wide variety of functionalities. For example, power and easy tools for piping and cabling. MATCAD that allows you to perform complex engineering calculation and also to use them to drive your model geometry. Simulation that allows you to perform linear static analysis. And we also have tools for speed up the framework design, tools for automate fastener geometry creation and generally hardware assembly. Human factor that makes you able to include a mannequin, a human model inside your assembly. Render tools, feature for easily creating and securely sharing augmented reality experiences, tools for working in a multi-CAD environment or explore design alternatives, modify imported model, multi-body design, and so on. In this case, we are going to focus on only some of them, that based on our experience can differentiate Creo. The first one we have chosen is piping and cabling. Creo includes a very user-friendly and powerful tool for piping and cabling. But now I give the floor to my colleague Luca for a very interesting demonstration on this topic.
Thanks Marco. Well, go to have a look on this tool. Determining the routes of pipe and cable can be difficult and time-consuming task. Beginning with the creation of a physical prototype and manually routing the pipelines and cables through it is typically error-prone and additionally is a long and tedious process. Because of the time and effort involved, the engineer often must accept the first route that works, not necessarily the optimal one. Even worse, when an engineering change is made to the design, it means you must start over by recreating the physical prototype and rerouting the cabling or piping, so wasting valuable time. Additionally, most companies that create the cabling prototypes don't document the cabling routes, which make it difficult to service these products. To solve this issue, a company will often send a service manager to the field, which can be very costly. With Creo PCX, these problems can be avoided. As you can see with the piping tool, you can route every type of pipe using the smart feature. The Ciscos on the component represent the start and the finish of the pipe, and the engineer can design the optimal through these, taking into account all the part dimension. Another important thing is the study of the flow direction. As you can see, it can be easily shown in the Creo PCX. If for the pipe routing there is the piping, for the wires and cables there is the cabling, a tool completely specialized in the electrical connection design. Here we have a dedicated cable tree to manage cabling data in the model. This tree is specific to the cabling application and has the following three views: cable view, bundle view, and connective view. This view allows you to see the harness structure in different ways. The cable view displays all the cables, wires, networks, and bundles in the active harness, and their information such as length, diameter, and from to. Additionally, if you expand the nodes, you can get information about spool segment and location points for each one. It enables an easy investigation and modification of routed cable. The bundle view displays bundle and their contents in the active harness. This view also displays the cables that are partially routed through a bundle. It enables an easy investigation and modification of bundles and their contents. Finally, the connectivity view displays all the designated connectors and the routing between them in the active harness. You can expand the routed wires to display their ports or bond ends. This view displays logical wires that are not yet routed as logical items. It also shows terminators and reference designated labels. The connectivity view helps you to easily see the connectivity structure of the active harness. It enables an easier investigation and validation of the harness design. The routing can easily be made thanks to the network, a spline that represents the highway through which the cables have to run. The function of this feature is to bridge the gap between mechanical and electrical engineers, allowing the first to study the routes without having to comprehend all the connection. As you can see, thanks to this, you need only to specify the two connectors that you want to match, and the wire is routed automatically through the network. The cables are shown with their own diameter, and it is awesome because help you to understand their actual footprint. Well, let's add the wires just routed to the main bundle quickly, and we are done. So, Creo PCX can dramatically reduce both time to generate documentation and the user expertise required to develop standardized manufacturing documentation, enabling more time to optimize design and the following greater flexibility when working with these manufacturing partners. Well, I'm finished, so I can get back the speaker to Marco.
Thank you very much, Luca. And now let's go on with the next point, human factor. Another peculiarity of Creo is that it includes a human factor model in its design essential license. Most of the time, in fact, a final product has to interact with a human, and Creo allows you to introduce a mannequin, a human body model, inside your assembly so that you can evaluate the human interaction, the usability, and the safety of your product. For example, you can introduce a reach envelope to evaluate if every part of your product is reachable or not. You can introduce a vision cone so you can understand if there is something obstructing the view. You can verify the compliance with safety, health, and workplace standards. You can perform lifting, lowering analysis, carrying, pushing or pulling analysis, and so on. But let's have you a quick example. In this case, I've already assembled a mannequin inside our assembly. The mannequin is a standard model you can retrieve from the mannequin library from PTC. And as you can see in this way, it's very easy to understand if it fits on the seat, if it is comfortable. I can open the mannequin tab to view some more options. And as you can see, I've already created some snapshot and some mannequin snapshot storing some posture. For example, I can activate this one that allow me to understand if the pedal is reachable or not, if there is something obstructing the way or not. I can activate the reach snapshot and to extend the arm, and I can evaluate the reach envelope so I can understand if every button, every handles inside our assembly is reachable. We have a lot of posture we can retrieve. we have this very large library, sitting, standing position, bending position. We also have micro postures, for example, the hand grabbing something, a finger pushing something, and so on. But we can also manually change the posture. Let's start by going back to the initial stance, and now let's say we want to customize our posture and grab this handle. It's very simple to do. We can simply select the point on the handle on the end we want to constrain, and we constrain to this point on the handle, and we can orientate the hand on the sagittal plane and then on the frontal plane. Or we can simply select a body segment, and then with this 3D dragger, we can move it around. For example, let's say we want to rotate the head to the bottom. We can also perform complex analysis, such as the visual field analysis. Let's say we want to center our cone of vision here in this point in the middle of the eyes, and we want to look at the ground. Then we can select some object and evaluate if they are obstructing the view or not. As you can see, the cone is updating in real time. And in this way, it's very simple to understand if the view is clear or not, or if I have to move some component away. As you can see, this is a very simple and easy to use tool, and helps you a lot in design a product for human interaction. You can understand safety, comfort, and usability. Let's get back to the presentation for the next point. Another answer to the question, why Creo, is its ability in design, collaboration, communication, and CAD consolidation. But what does it mean? Most of the companies need to integrate and work with design data from external partners, component subsystem from supplier, for example. So they have to interact with different CAD softwares. The statistics, in fact, says that on average, a company uses between 2 and 3 CAD systems. It implies a large cost of maintenance, license, and resource training. In this situation, Creo helps you a lot because it includes in the Design Essential license always some tools for integrating external CAD data, and also tools that allow you to easily edit any 3D data, any 3D external CAD models. Let's jump to a live demonstration. So let's say we want to modify the frame subassembly. Let's just activate it. And what Creo allows you to do, I can assemble directly, for example, a SolidWorks part. Let's just use some quick constraint to place it. And that's it. Please pay attention. I'm assembling directly a SolidWorks part. I'm not converting. I'm not importing. I'm assembling directly a SolidWorks part. As you can see, you retain the SolidWorks icon. You retain the SolidWorks extension. And this is very important because by doing in this way, we have the associativity with the original part. It means that if our suppliers update this part, we see the update in our assembly as well. If our colleagues in the other office do some modification to the SolidWorks part, we see the update in our assembly as well. Or we can also proceed in a different way. For example, we can modify the part by ourselves. So let's start by inserting some intelligence into the model. Let's start by understanding that this is a sheet metal part. And let's add some intelligence to the model with the flexible modeling tool. For example, let's recognize that this is a pattern. And we can also modify the pattern. For example, let's say we want 5 members with a spacing of 90 millimeters. That's it. Just a few clicks and I am modifying the part. Or let's add some walls. For example, here, 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 and on this edge too. And on this edge too. We can change the bend position and the shape and the angle of the wall. We are modifying a SolidWorks part. Let's have a look at the result in the assembly. Let's highlight the part. As you can see, this is a SolidWorks part I've modified, and it's completely integrated inside my assembly. So basically, we have assembled directly SolidWorks part. We have modified this part. As you can see, Creo allows you to easily collaborate in a multi-CAD environment and also implement, if you want, a consolidation in a single CAD environment. In this way, you can save a lot of time and a lot of money. Okay, now let's get back to the presentation with the next point. You have to remember that all the functionality we have shown until now are all included in the Design Essential license. But if you need more, if you want more, Creo offers an extremely wide range of advanced technology products. And the interesting thing is that you can buy, if you want, only what you need. And we are talking of a very wide range of technology: real-time simulation, generative design, fluid dynamic simulation, IoT, Internet of Things, additive manufacturing, augmented reality, mechanism design, and so on. We could talk days about them. In this case, in this presentation, we have chosen only a couple that stands out particularly in comparison to SolidWorks. The first one we have chosen is called Interactive Surface Design Extension. Consider that inside the Design Essential package, we have all the classical tools for surface modeling. I'm talking about technical surfacing, freeform surfacing, and so on. But if you want more, there's Interactive Surface Design Extension. With these tools, you can combine the power of the parametric modeling and the flexibility of freeform surfacing. Let's have a look at an example. So, in this case, we want to design a bike handguard, the left handguard. So let's open the model. The model, in this case, we have two bodies. Let's hide the first one. We will work on the shell one. As I said before, in the Design Essential license, we have all the classical surface tools, the technical surface tools, also the freestyle tools, and so on. But let me show you the style surface tools, the interactive surface design tools. First of all, what I can do is to just show you some images I've imported before. These images will guide our design. This can be the design of our handguard. This can be pictures you have done on your tablet or on paper, and you want to import to guide the 3D modeling. So inside the style environment, we are going to drop some curves and use them to create a surface. So let's start in a front view. And let's start by dropping a curve, snapping here on the surface, creating a middle point here, and snap on the right point. Then I can, for example, edit this curve, and I can edit it in a multi-view. So let's say I want to align this curve on the picture. So I simply select this point and I can drag it in a planar way. And in this situation, I can evaluate the impact of every modification from a multi-perspective view and a 3D view as well. And it's updating instantaneously. We can add also some control points here to have a better controls. Another point here to fine-tune my design. I can also do the same in a front view, obviously. Let's just select this point and drag it here. As you can see, the 3D is updating instantaneously. And also here. When I'm satisfied, I can confirm. And this is the result in a 3D view. An easy way to create a 3D curve. Then we are doing the same on the bottom, on this line. Let's drop the curve. 1 point here, snap, middle point here, and another snap here. Let's follow the same process. So we are going to edit the curve in a multi-view. So let's simply select this point and drag it here. Control point, as usual. Here. Another control point here. The same in a front view. Fine tune and better control our design. We can also, for example, change the tangency option to have better control. When I'm satisfied, I can confirm and go on. Now let's create some middle curve to guide and control the internal shape of our curve. So let's change the active plane and select the right one, the middle one. And let's drop a curve, a planar curve, simply by snapping on the curve I created before. You can see that from a side view. Let's do the same in this side. Drop a curve here. Let's change the plane and place it here and drop the curve here. See the same from the side view. As you can see, we have the snap on the curves. And in any time I can edit the curve. For example, I can drag the plane. And as you can see, the interesting thing is that the sides are parametrically linked to the side curves. So in any case, I retain this link. And the last curve on the right, we change the plane here again and drop simply the curve by snapping on the originals. Okay. Now I have all the curves. I can create the surface and I simply select all the boundaries and also the internal chains I've created before. And this is the final result. This is my surface. Then we can go on and create all the top and bottom surfaces. In this case, to save some time, I've already prepared the final results. Let's just retrieve it. So this will be the final surface. As you can see, I can in any moment go back in the style feature and modify anything I want. As you can see, we have a style tree with each entities I created, and I can modify it in any moment. As you can see, when I create a surface, I can also change the boundary option, tangency, curvature, acceleration, and so on. I can also perform, for example, a reflection analysis with this zebra plot to understand the quality of my surface. So let's say we are satisfied now. Let's just complete the design with some classical technical surfaces modification. For example, let's select this sketch and create a surface cut here on the bottom. And let's integrate this lot simply by merging the two surfaces. Let's perform another cut on the side. Here, let's fine-tune the design with some rounds. Let's add another round here, a third round in this case. And another round here. Then we are ready to solidify the geometry with 2 simple clicks, thickness, direction, and this is the final result. I can now hide all the curves and show their body. This is the final result. Easy. If I want, I can also make some modification, and so I can show you how easy it is. For example, let's activate this profile that is guiding all the design. If I change the dimension, all the design is updated. And this is because even if I've performed a freeform surfacing, all is done in a parametric environment. As you can see, this is a very powerful tool that gives you a flexible and easy, intuitive workflow for quick and easy creation, even of complex shapes. Okay. Next point. Live simulation. Another functionalities that makes Creo different is Creo simulation live. What live simulation means? It means that it provides instantaneous results. Basically, this technology integrates and enhances power tools based on graphic card and voxel method. And this tools is perfect for the initial concept design phases when you have to evaluate a lot of different alternatives and you need fast responses. It provides directional guidance on optimal design. Let's have a look at a quick example. So let's say this is the component we are designing, and we want to have a rapid feedback on its mechanical performances and analyze the impact of some modification. So let's start by starting live simulation, and as you can see, is directly integrated inside Creo. So you don't have to import and export neutral step files. You don't have to handle import error and so on. The interface is the classical Creo interface, very simple to use. We can introduce different study, structural, thermal model, fluid dynamic, and so on. In this case, we are performing a structural simulation. So let's just set up the load and constraint. So we are putting a cylindrical constraint and another cylindrical constraint here. Then we put a constraint on these surfaces. We are going to let the sliding on the X direction free and fixing all the other ones. And then we are using some force loads, 1000 in this direction, 2000 in this second direction, and the same on this surface. And we are ready to start the simulation. stop the simulation, and you will see that in few seconds we are going to have the results. The results are displayed in real time, and the simulation is complete. Very fast, very quick. For example, have a look at the von Mises stresses. I can change the scale to easily understand where the most stresses are, and to compare it with the critical stress. I can display the deformation. I can also animate the deformation. This is a scaled deformation, so I can easily understand how my component is going to behave. I can also perform some measures. So for example, I can analyze the maximum deformation on this surface. And sorry, the maximum deformation on this surface and save it. So it's going to update with the time. So let's try to understand the impact of some modification. So for example, let's try to change the section of the arms of this assembly. So let's modify this whip. Let's put a line here, and we're going to replace the arc with the segment, and we can do the same with the second part of this arm. So for example, let's try to show you this sketch and substitute the second section with this one. Okay, just regenerate the model and wait a few seconds for the results. As you can see, simulation already completed. I can also analyze the same way the results I showed before, and I can also compare results in terms of deformation to understand maybe if this modification is better or not. Let's perform another modification. So let's try to change another time the section, and let's show this sketch and change the internal section. So let's project all these elements and replace each segment so that all the references are not going to fail. Okay, and we do the same with the second part of the pipe. The second section will be this one. Okay, regenerate the models. As you can see, the section is completely different now. And when the simulation will be completed, again, I can compare the result. As you can see, this is a quick example that shows you that I can get instantaneous feedback on my design. This is a way to integrate the simulation inside the design process, so we can address problem earlier. It's simple, easy to use. You don't have to be an expert in the field of analysis to use it. Okay, let's get back to the presentation. And what I've showed you are only some highlights on what differentiates Creo in comparison to Solidworks. The final demonstration is that Creo has been nominated leader in innovation in 2023 by Able Research. This is an independent research that tries to understand how solution providers, the main providers, PTC, Siemens, Autodesk, Dassault, and so on, compare in terms of product functionalities and performance. And the result is that Creo is the leader of the ranking. The leader of the ranking. It acknowledges that PTC Creo provides the most current and state-of-the-art CAD technology solution. And that's it. I think this can be a good conclusion of the discussion we are having today. Thank you very much. And remember, remember that if you have any question, you can contact us at contatti@parameterdesign.com. Thank you very much again, and Richard, we can get back to you.
I'd like to extend a huge thank you to Marco for delivering such an insightful presentation today. So your expertise has truly enriched our discussions. Now, turning our attention to the heart of the matter, it's evident that one question has resonated strongly throughout our webinar: the disparity in licensing cost between Creo and Solidworks. So, guys, the entry-level package pricing is remarkably similar. Both Creo and Solidworks offer yearly subscription packages at approximately $4,000 per year. However, where the distinction lies is in the value proposition. So despite the comparable pricing, Creo stands out by offering a broader range of features and capabilities within its base package. This means that with Creo, we are not only getting access to a powerful CAD platform, but also a wealth of additional tools and functionalities that can significantly enhance your design workflows and productivity. In a sense, while the initial investment might appear similar, the return of investment with Creo is potentially greater due to its comprehensive feature set. So I hope this sheds some light on the question of the licensing cost and helps you guide your decision-making process. And so this is marked the end of our webinar. I hope you enjoyed, and we look forward to seeing you again for the next webinar. A special thank you goes to our marketing department for their hard work in putting all this together. And remember, the Parametric Design Canada will remain available to assist you with following this webinar. And please don't hesitate to contact us at our email address, contatti@parametricdesign.com, for any further question or information. Once again, thank you all for participating and have a great rest of the day. Bye-bye.